So in this video I'll be going through how to do algebraic long division with the intention of being able to answer questions where you are asked to find the quotient and the remainders. Okay, I'll just take this time out to say thank you for and welcome to all my new subscribers, and a special thank you to my ex and current students. Your support is very much appreciated. Now, algebraic long division isn't the most easiest topics to try and self-teach or by looking at some steps to understand what we're actually doing. Now, the best way to actually look at algebraic long division is to take you back in time to see how you actually look at long division using numbers. Now, there is a very common method and a very quick and easy way of doing long division using numbers. However, what we need to try and get an understanding of the next stage when we're working with algebra is to take it back to how primary schools teach students nowadays on how they do long division. So what we do is we're going to take, as an example, we'll take a question. So what we'll look at first is I will take a very simple maths question that could get presented to someone at primary school, which is going to be to divide 50,358 divided by 11. Now, in this particular question, how I could change this into an A-level question is to show that 11 is a factor of 50,358. Now, if something is a factor, then basically the remainder should be 0. So what we're going to do is I'm going to show you a rather old school method of doing long division, and then we're going to relate that to how we would do it for algebraic long division. So here, the remainder must be 0. So looking through this now, many of you would probably go to the point of where you set out your bus stop if we didn't have a calculator, and what we'll do is now I've purposely picked 11 because we all should know our 11 times tables, and we would just go on. So 11 doesn't go into 5, so we write 0, carry the 5. How many 11s go into 50? That would be 4, remainder 6. How many 11s go into 63? That would be 5, remainder 8. How many 11s go into 85? That would be 7, remainder 8. And then how many 11s go into 88? That would be 8. So, and here we've got a remainder of 0, so therefore we have proved that this is a factor, so 11 is a factor. Now, what I'm going to do now is show you a method that is pretty much taught at primary school and how we do the same thing. And now some of you may already do this now, which will be absolutely great, and you'll find the next transition to algebraic division a lot easier. So if we set up our bus stop again exactly the same way, 5, 8, and what we're going to do is we're going to take the first two numbers. So here we've got, obviously 11 doesn't go into 5, so we carry the 5, and we treat this as 50. So we think to ourselves, right, how many 11s go into 50? Well, that would be 4. And then what I'm going to then do is I'm then going to multiply this 4 by the 11, in which I get 44. And I write that underneath. And then what I'm going to do is take away these two numbers. So here I've got 50 take away 44, which is 6. And then once I've got that, I'm going to drag that 3 down, so I've now got 63. So then I'm going to have to work out how many 11s go into 63. That would be 5. And just note how that I'm writing the numbers underneath its corresponding values. So then I think, right, well, how many 5s? So if I just get a different highlighter. So then I'm going to then ask myself, how many 5s go into 11, in which I've got 55, and I take those two numbers away, in which I end up with 8, and then I drag the 5 down, so I get 85, and then I ask myself, how many 11s go into 85? That would be 7, and then I do 7 times 11, which is 77. I then do take away, so I've got 8, and then I finally drag that 8 down to get 88, and then how many 11s go into 88? That would be 8, and then do 8 times 88. Now I'm just going to carry on because I know that it's going to struggle to see it. So I've got 8 times 11, which is 88, take the two things away, end up with 0, and as you can see, that as I've got remainder of 0, 11 is a factor of 50,358. So what I'm going to do now is I'm going to do another example very much like this, and we'll show how we do get a remainder in terms of this, because like I said, not always are you going to end up with questions where you are finding a factor, but at least we've done it with numbers, so hopefully when we move on to algebra in our next set of examples it will make a bit of sense. So let's have a look at another calculation. So let's stick with the 11 times table just because it's easier for us to understand. So let's go for 236 divided by 11. So here I'm going to do, I'll have some more space here, so let's do it here. So I've got 11, 2, 3, 6. So how many 11s goes to? None. How many, so I can write a 0 there. How many 2s going to, how many 11, sorry, goes to 23? That would be 2. So I do 2 times 11, which is 22. Take the 2 numbers away, so I end up with 1. Then drag the 6 down. How many 11s go into 16? That would be 1. 1 times 11 is 11. Take the numbers away, and this here now is my remainder. Now, if we're doing this form of calculation, so this is very, very similar how I could write this using algebra without messing up the numbers. So let's go to that. So I've got 236 divided by 11 is, I could write this as an improper fraction, so as a mixed number, sorry. So here, using this information I've got here, I know that 11 goes into 236 21 times. I know that the remainder is 5, and the original divisor was 11. So that's how I can use this information to work out questions like this. But also, how I could also write this, which in a more non-conventional way, is to write this as 21 plus 5 over 11. Now, you would never have done this before because it kind of doesn't make any sense. It's like 21 and 5 11ths. However, when you move on to algebraic division and you do end up remainder, then this is kind of how we need to write it. Now, in terms of giving these things kind of names, that this number here of how many actually goes into the number is what we call the quotient. And this number here, unsurprisingly I should say, is what we call the remainder. So in the introduction when I talked about what using long division to find the quotient and the remainder, well, that is what we're doing. And going back to our bus stop extravagance here are those two aspects. So this on top of your bus stop is what we call the quotient, and the thing at the end right at the bottom is always going to be our remainder. Now if we have got something that is a factor, that's going to be equal to 0. However, if you do have a remainder, then it will end up here. So let's just do one last example just to make sure you've mastered it. If you want to pause the video to have a go at this one yourself, then please do feel free. I'm still going to go through it just in case you are still unsure about what we are doing. So let's go for 4,304 divided by 12. And again, this could be any number. It could be 23, could be 76, could be anything. So like I said, I'm just picking 12 just as an easy example for you to easily understand, because the method is more important rather than actually finding a really difficult question. So setting this up, we've got 12 and we've got 4304. And again, going through the notions, I've got how many 12s go into 43? Well, that would be 3. 3 times 12 is 36. Take those two numbers away and I end up with 7. Drag the 0 down, so I end up with 70. How many 12s go into 70? That would be 5. 5 times 12 is 60. Take the two numbers away, I end up with 10. So even though I've got a double digits here, it doesn't really make a difference. So I drag this number down, so I've got 104. How many 12s go into 104? That would be 8. 8 times 12 is 96. Take the two numbers away and I've got 8. So here what I've got is I've got 4304 divided by 12 is 358 plus 8 over 12. So here this is my quotient and this is my remainder. So what we're now going to move on to is looking at algebraic long division. Now I've purposely picked two questions just to get us started with that we're going to do in a very, very similar way to what we did when we had numbers. So in the first question it says, using algebraic long division, show that x plus 1 is a factor of x cubed plus 3x squared minus 12x minus 14. Now, if it wasn't for the fact that they mentioned algebraic long division, which is mentioned here, then what I could do is I could use the factor theorem to substitute x equals minus 1, substitute it into this polynomial, and it should equal 0. And if it does equal 0, it therefore shows that x plus 1 is a factor. However, because it says algebraic long division, I have to show this method in order to get the marks. So if we get started, let's get a decent colour pen. So let's go for our purple. Right, so what we're going to do is going to set this question up in the exact same way. So what's going to go outside our bus stop is x plus 1, and what's going to go inside our bus stop is going to be our polynomial. Now, I haven't really done steps on this one because by doing written steps it's very, very difficult because every question is going to be slightly different. However, if you are wanting some written steps, then just drop me an email at the above email address and I will be happy to send you some step-by-step guides. However, I will try and go in slow and in terms of explaining where and what I'm writing and where it's all come from. So hopefully how I've set this question up makes a little bit of sense in terms of what goes inside and outside our bus stop. And so what we're now going to do is go on to answer this question. So the first thing we need to look at is we need to see what x cubed divided by x is going to be. Now another way of looking at how I personally do it is I think to myself, what do I need to multiply x to get x cubed, in which this case it's going to be x squared. Now from this what I'm now going to do is multiply this x squared by the two things outside our bus stop. So I'm going to do x squared times x, which is x cubed, and I'm going to do x squared times positive 1, which is positive x squared. Now just like before, what I'm going to do is I'm going to take away those two expressions away from each other. So if I get a different colour pen this time, so let's go for different contrasting colours, let's go for blue. And so what I'm going to do is x cubed, take away x cubed, which is nothing. Now if you've done this correct, the first two things you subtract should cancel out. So far so good. The next thing I then need to do is take away 3x squared, take away from x squared. So just be careful with the signs, particularly when you've got two negatives, because this is again where a lot of students go wrong, is messing up on those signs. So here I've got 3x squared, take away x squared, which leaves me with 2x squared. So now what I'm going to do is I'm going to drag that minus 12 down, because I always want to have two terms, because I've got two terms there. If I had three terms here, I would drag, so I've got three terms, but here I've only got two, so there we go. Now what I now need to do is think to myself, what is 2x squared divided by x going to be, or what do I need to multiply x to get 2x squared? So here I need to multiply that by 2x, in which then if I multiply 2x by these two things here, then what I get is I would just change the colour again. Let's go for red. So here I'm going to have 2x times x, which is 2x squared, plus then times 2x times plus 1, which gives me 2x. And then what I'm then going to do is take away the two terms again. So here I've got 2x squared, take away 2x squared, which leaves me with nothing. So as those two things cancel out, it signs are good that I'm doing the right thing. And then what I then need to do is do minus 12 minus positive 2, which leaves me with minus 14x. And then what I'm now going to do is drag this minus 14 down, and there we got there. And now what I'm going to do is repeat the process. So this time what I now need to do is, if I use a different colour pen, is now think to myself, right, okay, I've got minus 14x. What's minus 14x divided by x going to be? Or what do I need to multiply x to get minus 14x? Well, that would be minus 14. So then if I do minus 14 times x, it leaves me with minus 14x. And then I've got minus 14 times positive 1, which leaves me with minus 14. And have I done the right thing? Because when I take away these two things, I've got minus 14x minus minus, two minuses make a positive, so they cancel out. And I've got minus 14 minus minus 14, which also leaves me with nothing. Or what would be better at that stage is writing 0. And so here what we've done, so as your remainder, so as the remainder is 0, x plus 1 is a factor. So again, it's always good practice for you to write down. I know it's a bit of a pain and it's quite mundane to write this down, but it's always a good remainder rather than showing it equals 0, because the question does not say using algebraic long division show the remainder is 0. It's saying show that is a factor. And what this statement here does, it explains that because the remainder is 0, that the original divisor must be a factor. So what we're now going to do is do the exact same, but this time for question B. And we'll do the same format. So this time what we want to do is we want to show that x minus 2 is a factor of this polynomial. So what goes outside the bus stop is x minus 2, and what goes inside is our polynomial. So I've got x cubed minus 2x squared minus x plus 2. So then again, I'm going to start with this first term in our polynomial and then think to myself, right, okay, what's x cubed divided by x, or what's x times, what do I need to multiply x to get x cubed? That would be x squared. And then I've got to do x squared times x, which is x cubed, and minus 2 times x squared, which is minus 2x squared. Now I'm going to take away those two things. So here I've got x cubed minus x cubed, which is nothing, and I've got minus 2x squared minus 2x squared, which also leaves me with nothing. So the question is here, what do I carry forward? Well, here, what I now need to do is carry these two things down. So even though I've got nothing left to carry forward, if that happens, which it does happen, I can now just move on from here. So from this, what I've now got is x times, what do I need to multiply x to get minus x squared? Well, that would be minus 1. So note that as I haven't got anything with a coefficient of x, I've purposely left this blank because I want to work in nice equal columns. What I don't want to do is get confused by writing minus x, and it's always good to have clear presentation at this top here. So here I've got minus x, so here's my new number. So what do I need to multiply x to get minus x, which is minus 1? And now what I'm going to do is multiply minus 1 by these two things here. So minus 1 times x is minus x, and minus 1 times minus 2 is positive 2. And again, I'm going to take those two things away. Minus x, take away minus x is nothing. So again, clear indication I've done the right thing. And positive 2, take away positive 2 is 0. And again, as the remainder is 0, x minus 2 is a factor. Now in this particular question, what we've got is the question specifically asking us to find the quotient and the remainder of these algebraic long divisions. And what I'm going to do is I'm going to show you how to do that using this method. Now what I've done is I've purposely picked these 4 questions because there is something slightly different with each of these questions. Now for the first one, it's very, very similar to what we did above, but here we're expecting a remainder, so we're not going to have a clear factor. With question B, what we've got is we're missing a coefficient of x, so don't always think that you're always going to end up with x cubed and it's just going to go down in degrees of x till we get to our constant. In question C, we have got that we've got a 2x, so the coefficient of x is more than 1, and what happens there. And in question D, what we've got is we've got the same degree of x in both our numerator and our denominator, but also here we've got a quadratic equation at the bottom, which is a bit bigger and longer than what we've got in our numerator. And what I'm going to do is just show you how we do this method, how we manipulate this method to go about answering these types of questions. So, starting off with our first one, what we have got is, so again, I'm going to set this up as x minus 3, in which I've got x cubed minus 2x squared plus 4x minus 7. So again, going through this, what do you need to multiply x to get x cubed? That would be x squared. So x squared times x gives us x cubed. X squared times minus 3 gives us minus 3x squared. Again, I'm going to take away those two terms, in which the first thing disappears, which is great. Then minus 2 minus minus 3 gives us positive 1x squared. I drag the 4x down, and then think to myself, what do I need to multiply x to get x squared? Well, that needs to be another x. Then I'm going to multiply this plus x by the two things outside the bus stop. So I've got x times x, which is x squared, and x times minus 3, which is minus 3x. And then what I'm going to do is take away those two things again. So I've got x squared, take away x squared, which is nothing. 4 minus minus 3 is positive x squared. And then I drag the minus 7 down. So I've got, what do I need to multiply x to get x here? By 7x. So I need to multiply that by positive 7. So I've got 7 times x, which is 7x. 7 times minus 3, which is minus 21. And I take away those two things, so minus 20 minus minus 21, which is positive 14. So here, how I want to write this out? So here, I've got my quotient. So this here is my quotient. And here, I've got my remainder. Now, there is a key way of how we write this as an answer down, in which how I'd write this down is I would write this as equals x squared plus x plus 7 plus 14 over x minus 3. And that is how you want to be writing your answer out. So this part here is our quotient, and this part here is our remainder. And so when you get asked these questions, this is exactly how you're wanting to set it out. So if, let's say, r was minus 14, then obviously you could write that this here is a minus, but let me just get rid of that because that's going to be very confusing. However, as it's positive 14, we're adding. If you want, you could stick the minus there and you should still get marks for it, but obviously it's good practice for you to simplify a plus and a minus. But like I said, hopefully that comes up in another question where we have got a negative reminder. So moving on to question B, excuse me. So with question B, we've got x plus 3. Now, the difference with this particular question is we're missing a coefficient of x. So what I'm going to do is I'm going to write x cubed plus x squared. Now, if you do have a missing coefficient of x, what I recommend that you do is write 0x plus 10. And I'm just going to highlight that just so that it's good practice, because when we are dividing, we still may end up with something x on top of our bus stop. So we might end up with something x just going there. So if you have got a missing, now your degrees of x should be going down sort of in descending order. So if you are missing something, then just write 0. Just like if you're missing a constant, you write 0. If you're missing an x squared, you write plus 0x squared, just so that it's easy for you to go. And I'll show you what difference that makes when we go through the question. So going on from this, we need to see, well, what do we need to multiply x to get x cubed? That would be x squared. So then I multiply this x squared by the two things here. So I've got, so by x plus 3. So I've got x cubed plus 3x squared. I'm going to multiply these out. So here, subtract these two terms. So I've got nothing, those two cancel out, which shows that I'm doing the right thing. I've got x minus 3x squared, which gives me minus 3x squared. So now I'm going to drag this 0x down. And then what I've now got to do is say, well, what do I need to multiply x to get minus 3x squared? Well, that would be minus 3x. Then I'm going to multiply this by the two things outside the bus stop. So I've got minus 3x squared minus 9x. And I'm going to take away those two things together. So I've got this cancels out. 0 minus minus 9 becomes positive 9x. And then from here, I'm going to drag the plus 10 down. So from this, I'm now going to think to myself, what do I need to multiply x to get 9x? Well, that would be plus 9. And then I've got 9 times x, which is 9x. Positive 9 times 3 is positive 27. And I'm going to take those two things away, in which I end up with 9x minus 9x cancels out, and 10 minus 27 gives me minus 17. So here, my quotient is what's highlighted in blue on top of the bus stop, and my remainder is minus 17. So how do we go about writing this as an answer? Well, how this will be written as an answer is x squared minus 3x plus 9. Now you could either go for plus minus 17 over x plus 3, which would be absolutely fine, but it is very good practice for you to simplify this plus and a minus. So what I'm going to do is I get rid of that plus and a minus, and I just write it as minus, and there we go. So that'll be an example where we do have a negative remainder. What do we do and how do we write this out? Well, we could write it either as a plus but make sure the minus is still on a 17, or I can just simplify the plus and the minus to make a minus, and hopefully that makes a lot of sense because I've said plus and minus a lot of times. Now in question C, what we notice is that here we've got our sort of divisor is having a coefficient of x that's greater than 1. So what I'm going to do is do 2x plus 3, and I've got 4x to the power of 4. Now you can see I've got a quartic polynomial. So here I've got 4x to the power of 4 minus 3. Now as you can see there, I'm missing, and again it's very easy done because I've almost done it myself. So here I'm missing an x cubed, so I'm going to write minus 0x cubed minus 3x squared plus x plus 2. So as you can see, very, very easy, and again a little bit embarrassed that I forgot that one to do off, but at least it shows that it can be done. So going on from this, what we now need to do is do exactly the same process. So here I'm going to think to myself, what do I need to multiply 2x to get 4x to the power of 4? Well, that would be 2x cubed. So if I then multiply 2x cubed by these two things here, then what I'm going to get is I'm going to get 4x to the power of 4 plus 6x cubed. And then what I'm going to do is I'm going to take away those two things. So then if I get a different colour pen, so here I'm going to do 4x to the power 4, take away 4x to the power 4 is nothing. So again, a sign that I'm doing it right. And then I've got minus 0 minus positive 6 gives me minus 6x cubed. And then what I'm going to do is now repeat the process. So here what I'm going to do is I'm going to think to myself, what do I need to multiply 2x to get minus 6x cubed? Well, that would be minus 3x squared. And then what I'm going to then do is, well, I forgot to drag the 3x squared down. So then what I'm then going to do is multiply the 3x squared by these two things outside the bus stop. So I've got minus 3x squared times 2x, which is minus 6x cubed, and minus 3x squared times positive 3 gives me minus 9x squared. And then what I'm going to then do is take away those two terms, and again, quick change of colour. Let's go for pink. So here I'm going to do minus 6x squared cubed minus 6x cubed is nothing. Again, signs are doing it right. Then I've got minus 3 minus minus 9, which gives us positive 6x squared. Then I'm going to remember this time to drag the positive x down, and then think to myself, what do I need to multiply 2x squared to get 6x squared? Well, that would be plus 3x. And then multiply the 3x by the two things outside our bus stop, which I've got 6x squared plus 9x. I then take away the two terms, so 6x squared minus 6x squared is nothing. Again, signed on it right. And x minus positive 9x gives me minus 8x. I then drag the positive 2 down. I then ask myself, what do I need to multiply? So go for green. What do I need to multiply 2x to get minus 8x? So that would be minus 4. I then times minus 4 by the two things here. So I've got minus 4 times 2x, which is minus 8x. And then minus 4 times positive 3 gives me minus 12. And then take away those two terms, which that disappears. 2 minus minus 12 is positive 14. So from this information, I've got my quotient, which is this, and my remainder, which is at the bottom, which is here. So how I'm going to write this answer out, so let's get my trusted purple pen. All right, there you are. So how I'm going to write this answer out is I'm going to write 2x cubed minus 3x squared plus 3x minus 4, and then it's going to be plus 14 over 2x plus 3. And where that 2x plus 3 comes from is the original divisor. So what we're going to do now is move on to our last example, which, if you just bear with me to get rid of all of this. And let's have a look at our last example. So in our last example, what we've got is, what's going on there? So in our last example, what we've got is we've got our degree of x being exactly the same. So if I just move that screen down, because I'm a little bit getting a bit of it. There we go. Right, so with question D, here we've got a quadratic as our original divisor. So let's set up the bus stop. So I've got x squared minus 4x squared plus 5. And what I'm going to do is I'm going to sort this out as my highest degree of x. So I've got x squared plus 0x plus 3. Now from this, what we then need to do is we go through the same notion. So how many x squareds go, what do I need to multiply x squared to get x squared? And that would be just a constant of 1. So now what I'm going to do is, so now I've got that 1, is saying, well, what do I need to multiply? What's x squared divided by x squared? Or what do I need to multiply x squared to get x squared? That will just be a single 1. I've written it there because we want to try and keep our constants in the same column. So now what I'm going to do is I'm going to multiply our quotient by the 3 terms outside the bus stop. So here I'm going to do 1 times x squared, 1 times minus 4x, which is minus 4x, and I'm going to do 1 times 5, which is positive 5. And again, I'm going to take the 2 things away. So because I've got 3 terms in my original divisor, I'm going to end up with 3 things at the bottom here. And again, signs that you're doing the right thing is that the first term should cancel out. So then I've got 0 minus minus 4, which is positive 4x. And then I've got 3 minus positive 5, which leaves me with minus 2. So what I've got is I've got this here being my remainder, and I've got this here being my quotient. So writing the answer to this question out, what I end up with is 1 plus, and then I've got 4x minus 2 over the original divisor of x squared minus 4x plus 5. Now there are examples where you could end up with an improper fraction where your degree of x squared x is greater at the top than it is at the bottom, in which you can do a slightly modified version of that, but what you'd end up with is exactly the same process, but it's just a little bit different, which I'll be honest, it's not really a level that's covered. However, if you do come across that question, drop me an email and I'll be more than happy to do either another video or some written instructions on how to do that. Well, I hope this makes sense, and obviously what I'll do is I'll post up some, if you would like some extra questions with some answers, drop me an email, drop me a tweet at 162maths, in which I'll be more than happy to send you any further material you wish.